Hello guys, welcome to my class. Today we are going to learn how to analyze and design a rectangular water tank. Okay, so first open STAAD Pro, click on new project, click on space, give a name, water tank or rectangular water tank. You can choose a location. Length unit for me is meter and force unit kilometer. Then click on next and click on add beam, then finish. Okay, so I am going to design or modeling a water tank rest on 3 meter or say 4 meter column. Okay, so we are going to first create a column, then a rectangular tank. Okay, so click here on the 0 and on the 4. Now this is our column. Then up to 7 meter it's our tank. Now it is the height, length will be 4 meters, so 0 to 4 here, and again it goes to the downward. This is the tank and this is the column. Now close it. Okay, then escape it, switch off the snap node grid. Now add this node to beam. Okay, now the outside is rectangular tank and downward is column. Sorry, we have to delete this one. Okay, now we have to shape this, so select all the nodes. Okay, or select all the beams and go to transitional repeat, because if I copy in the positive Z direction, then just say beam or member or nodes will copy it, not the x-axis. Okay, let's see. Now step 1, and our height is 3 meter, rectangular tank height is 3 meter, length is 4 meter, and width will be also 4 meter, or you can say 5 meter. Okay, and make sure you have select link step. Okay, now that's what happened. If I copied just here, then they are not linked. Okay, so delete those two member, we are not using that. So now the upper side is tank and downward is column. Okay, if you want to give some heights of the tank, you can give it. Okay, for that you have to add the beam onto columns, because if the height is maximum, then there will goes live load, dead load, and also wind load and seismic load. Okay, so now we have to give some supports. So go to front view, click on support page, create, and support is fixed, add, click on the support, select the nodes you want to give the supports and assign to selected nodes. As I selected the nodes and assign it, yes, now our column is structure is fixed. Okay, close the dialog box. Now goes to the main property page. Okay, at first thickness for the slab, our thickness will be 0.15. okay, now add it, close it, and our rectangle shape for the column and beams, our rectangle column will be 0.5 by 0.5 and our beams will be 0.5 to 0.4. okay, then add it, close it. Now we have to create the plates for the tank. For that we have to go to generate surface meshing. okay, now click on generate surface meshing and select the 4 nodes or select the one side of the tank. Now select it. Now this shape is quadrantal, so click on quadrilateral meshing and OK. Now the division, you can increase or decrease the division, but I am going to give it to 1 because the plate or the RCC structure will one side and one plate. okay, let's see what happened. Click on apply. Now when you click the plate cursor and select it, then you will see this is one plate, and actually this is one plate. In the real life, real works, they are going to construct this as a one wall, or you can say one plate. okay, now again we have to create the 4 plates. Rest of the 4 plate, click on generate surface meshing and select those 4 plates or sides. Now quadrantal meshing, division will be 1. You know the reason. Apply. Then these sides quadrantal. okay, division 1. Apply. This side, just select the node, quadrantal meshing, division 1. Apply, and the base of the tank. Now click the plate cursor, select the plate cursor and say this is one plate. okay, now we have to give the member property. okay, so at first plate thickness is goes to the plate, so select the plates and assign to select, click on assign to selected plates, assign yes. Now select the column property and select the columns. Go to front view, press Ctrl from your keyboard for selecting multiple columns or member. okay, these are column, and click on assign to selected beams and assign it yes. Now the beams. okay, select the beams, go to the front view, select the beams. These are beams. Sorry, first you have to select the property, then you have to select the member you want to give the property. Now these are beams and these are beam property. I click on assign to selected beams and assign yes. Now go to 3D render view. You see this is our structure, this is our tank, and these are column and beams. okay, now we have to give loads. Go to load page, click on load case detail, add loading type dead, give dead, add live, add close. For the dead load we just give the self weight, add, and we keep also the plate load. okay, so go to plate loads, plate on full, pressure on full plate, you can give it to the live load. Just assign self weight to the whole structure, assign to, for that goes to assign to view, assign yes. Now go to the live load. Live load is for water. Okay, go to plate load, plate on full pressure. This pressure goes in the bottom of the tank, or this is the bottom of the tank. So the give the pressure minus 60 kilonewton. Okay, in the global y-axis, add it, close it. Now select the plate. Now select the plate. Plate is selected. Select the property and goes to assign to selected plate. Assign it yes. Now you see the pressure is downward on the plates. Again go to the live load, add plate loads and goes to hydrostatic. Okay, now hydrostatic is for the water. Select, click on select plates. Now you have to select plates, which plate you want to give the property. Okay, now I'm going to select this plate. Okay, now see 21 plate is selected. This is 21 long plate. See, you can select and click on done, and we have selected this plate. And you can see W1 is minimum global axis. This is the W1 load and W2. W1 load is downward and W2 load is upward. Okay, so give the W1 load is 50 kilonewton. Sorry, and this load will be 2 kilonewton, and it goes to the negative z axis. So interpolation along global axis will be z, and it will be local z. Give them minus. If you don't understand, just select loads, select interpolation along global axis, and direction can be changed later. Okay, so don't have to worry about it, and add it, close it. Now select this load. See, this load is downward, so I am doing wrong. So again I have to edit it. Double click on the load and have to just change the value. This is going to be positive. Okay, change it, and you see the loads. See, this is on the inner to outer. This load is goes to inner to outer. In the bottom the load is maximum, in the top bottom is minimum. Okay, again go to the live load for rest of the loads. Forgive the rest of the load. Go to the live load, add plate load, hydrostat. Go to select for select the load. Now we select the 21. Now I'm going to select 23, opposite of the load, opposite of the plate. Click on done. Give the load minus 50. It is going to minus 2. Interpolation along global y axis is y, and it is local z. Add it, close it. Now you see the load. It is inner to outer side, so we give the perfect load or perfect pressure on the plate. Again go to the live load, add plate load, hydrostat. Going to select plate load and select this. We have selected 21, 23, and going to select 22. Then done, and the pressure will be 50 and 2 in the y-axis, and it will be global X. Add it, close it. Now see the load. See, this is inner to outer. Now if you don't understand what I have done, now see this load. See, when I select the load, they select or they highlight the load applied. Now watch carefully. If I go to the isometric view and select this load, now see the down pressure is 50 kN per meter square and upper load is 2 kN per meter square. Okay, the local pressure is in the Z direction, local Z or global Z. Now see, this is the Z, this side is positive Z, so we give the value positive, and this side, or you can say in your side where you sit, where you watch the video, this is a negative, and your computer or your laptop other side is negative. Okay, now again this side in the local Z. Okay, now this side is in your side, that is the negative one. Okay, this is the negative and other side is positive. Okay, now going to x-axis, this is x-axis, x positive, and this direction is negative. So in the direction, positive direction we give positive value, in the negative direction we give negative value. Okay, it is the same. In the Z direction it is negative, Z in the your side is Z, so we give the positive value. See, positive value, and this side is negative value. Okay, again we go for the rest load, go to live, add plate load, hydrostat, select plate. Now for the 20 nm plate, click on done. Okay, now pressure is -50 because it is in the minus x direction, it is going to -2, interpolation along global y axis y, and it is global x minus, add, close. Now select the load, it is on the inner to outer load. Okay, now all our loads are given. Now I have to give the member load. Okay, now you know how to design columns and beam. Okay, you can design it. I am just showing how to design the rectangle tank. Okay, now go to the analyze. Now this perform analyze, go no print, add it, close it, go to analyze, run analyze, save. You can see no error, no warning, no notes, so all the things are right. Click on done. Now I have to design it. For that, go to design, concrete design. We are going for BS807 for want to know the rods on what they are using, but you can go to the IS456 because I'm in the previous classes I showed you how to design plates or slab according to IS456. Okay, now I'm going to use BS807. Okay, now go to select parameters. Now we are going to select clear, compressive strength and yield strength. Okay, click on OK. Now define the parameters which I have chosen. Now for cover will be point. Now this is a water tank. Okay, so we give the cover much larger than the rest one, because cover is given for the water can't go through the structure in the rods, or you can say if there goes in the structure and there will harm the rods. Okay, now we are going to give the cover 30 millimeter. Okay, then add it. Now compressive strength will be 20,000. Now this is 20,000. Add yield strength 415,000. Add close. Now it goes to the plates, because we are going to design the plates only. Go to the plates, assign, select the clear, assign to selected plates, assign it yes. Similarly, compressive strength goes to the selected plates, assign yes. Yield strength, assign to selected plates, yes. Now I am going to comments and design slab element, add close. Now select design element, select the plate and click on assign selected plates, assign yes. Now going to comments, analyze, perform analyze, OK, analyze, run analyze, save. Now see, there is no error, no warning, no notes. So we have done all the right things. Now go to the output file. Done. Now this is a complete design. Okay, now you see the bottom, top bar. Okay, what is the cover for all the slabs or all the plates, they are showed here. Okay, now go to the post processing. Okay, and go to the plates, stresses type. We are going to see the maximum absolute, apply. Okay, now you see the stresses where it is the maximum in the bottom or the center. Okay, different stress in the different area. Okay, now you go to the reaction for columns or the loads has been given. You can go to the reports for plates, or you can go to the output for plate stress. Okay, now this is your output file. So that's it. That's how we're gonna design a rectangular tank. Okay, so thank you for watching my video and keep subscribing on my channel. Okay, so bye.